Hey guys, this video tutorial was for A on assignment number 66, force gravitational and uniform circular motion. We know that a string spinning something in a circle would be force tension. Force tension is the force centripetal, making it go in a circle. If you were running on a track, that'd be force friction, that is acting as the force centripetal, and so forth. But right now we're going to be talking about what would the force centripetal be if I had a planet that was rotating around another planet in a circular fashion. Okay? Well, it's centripetal force, obviously, but the force that is acting as centripetal force would be force gravitational. Okay? We have this weird equation right here, but it's really not that weird. Okay? But what is gravity? Okay? Gravity is a force that you have based on how much mass you have. So anything with mass can exert a force gravitational, right? Anything with mass can exert a force gravitational. If you have mass, you have a gravitational field. Gravitational field exerts a force at a distance, right? I don't need to actually touch this red planet with the blue planet in order to get it to make it rotate around it in a circular form, right? You don't ever have like these actual physical lines or strings coming out of the planet to make it do that. It's just a field force, okay? So let's talk about what we can do to change the force gravitational in this real quick. So first off, let's talk about what this all means right here. This big G is the gravitational constant, which you're going to have. This is Cavendish came up with this. And big G is equal to, I'm talking about little g a lot, but this big G now, 6.67 times 10 to the negative 11. And it has like a really messed up unit. I'll give it to you right now. Newton meter squared per kilogram squared. And it's not too important, but it's if you're interested, that's what it is. So let's see. Obviously, what do you think is going to happen? What do you think is going to happen if I increase the mass of the red planet? Right? What do you think is going to happen to force? Well, you'd expect it to go up, and that's right, because as my mass of mass 1 goes up, the force is going to go up. What happens if I decrease mass 2? If I decrease mass 2, I'm going to decrease force gravitational. When I decrease one and it decreases the other, this is called a direct relationship. Okay? So if they're all on the top, they're going to be directly related. Now, look at the radius on the bottom. In your experience, the further you are from something, do you think you have more or less gravitational attraction to it? Right? Less gravitational attraction. If I move far away, I'm going to have a lot less gravitational influence on my far off objects here. So if I increase my radius, right? And what do I mean by radius? The radius is the distance between the two centers. If I increase my radius, it's not going to increase the force gravitational. That doesn't make any sense, right? It doesn't make logical sense. If I increase the radius here, I'm going to decrease my force gravitational, but it's not that easy. I'm not just decreasing it, I'm decreasing it by a square. Okay, I'm decreasing it by a square. So we call that an inverse square law. Okay, inverse square law. Meaning if I increase or decrease this distance, it's going to change the force by a factor of a square. Okay, so if I double the distance, I'm going to decrease it by a fourth. Okay, so just keep that in mind. We'll have some practice on this. All right, good job, guys. Inverse square law, radius. Direct relationship, mass.